Imagine for a moment a creature that is everywhere. It is beneath your feet every time you walk through the park, it is in the air you are breathing right now, and it might even be living inside the technology you will use in the coming decades. For centuries, we have ignored them. We thought they were simple forest decorations, or worse, a pest. But we were wrong. What we see on the surface, the mushroom, the toadstool, is only the tip of the iceberg. It is like seeing an apple and thinking that is the entire tree. The true magic, the true beast, lives underground. I am talking about fungi, a creature that is neither animal nor vegetable, but something in between that has survived 5 mass extinctions. And now, in the 21st century, scientists are realizing that these organisms could hold the key to solving our greatest problems, from plastic pollution to building bases on Mars. I'm Rafael Gonzalez and you are watching NovaGea. Today, we are not going to talk about mushrooms for pizza. Today, we are going to discover how mycelium is about to change the world as we know it. To understand this revolution, you first have to understand what mycelium is. Forget what you learned in school about roots. Mycelium is not a root. It is the actual body of the fungus. An infinite network of microscopic threads, called hyphae, that function in a way eerily similar to the internet, or even your own brain. Think of it this way: mycelium is the stomach of the forest, but it is an external stomach. It grows inside its food, digesting dead matter and recycling life. Without them, the planet would be covered in miles of animal and tree carcasses that would never decompose. But here is the strangest part. They don't just eat, they communicate. Recent studies, such as those published in Royal Society Open Science, have analyzed the electrical impulses traveling through these threads. And what they have found has left us chilled. Fungi generate voltage spikes that group together like words. It is estimated that an average fungus has a vocabulary of about 50 words. They aren't reciting Shakespeare, of course, but they send messages about where there is food or if there are dangers nearby. They have grammar, they have syntax. It is an underground social network, the Wood Wide Web, connecting trees and plants, exchanging nutrients for sugar, like a biological stock market that never sleeps. And if this sounds like science fiction to you, wait until you see what we are doing with them. Because if they have a language, what happens if we learn to speak it? We live in the age of plastic. And plastic is a problem. It takes centuries to disappear, and it is poisoning our oceans. But what if we could grow plastic instead of manufacturing it from oil? This is where mycelium shows its engineering side. Current companies have discovered that if you take agricultural waste, corn husks, sawdust, things we would throw in the trash, and add mycelium, something fascinating happens. The fungus acts as a natural glue. In a matter of days, the mycelium devours the waste and weaves a solid, light, and resistant structure. This is no longer a laboratory experiment. Giants like IKEA or Dell have already started replacing polystyrene, that is, white styrofoam, with fungal packaging. The big difference? When your package arrives, instead of throwing the foam in the trash where it will last 500 years, you throw it in your garden. In 45 days, it's gone. It has turned into compost. It is the perfect cycle. But it doesn't stop at boxes. Perhaps the most revolutionary mycelium technology isn't for building, but for destroying what we have left over. In 2011, a group of students from Yale University traveled to the Amazon rainforest and returned with a find that seemed impossible: Pestalotiopsis microspora. This fungus has a unique superpower. It eats polyurethane. It is capable of feeding exclusively on plastic, breaking its chemical bonds as if it were breakfast. And here is the key fact: it can do it in anaerobic environments, that is, without oxygen. This is the holy grail of waste management. Imagine being able to inject this fungus into the bottom of massive landfills, where air doesn't reach, and letting it devour tons of plastic waste from the inside. Or even, in the future, having a small biological reactor at home where your old containers disappear, digested by nature. But would it be possible for the same organism that devours our waste in a landfill to become the most exclusive material on the runways of Paris? Dramatic pause. Now let's talk about fashion. Luxury brands like Hermes or Stella McCartney are investing millions in mycelium leather. It is soft, it is durable, and most importantly, to make a traditional leather jacket, you need to raise a cow for years, wasting thousands of liters of water and resources. To make a mushroom jacket, you need a few weeks and some sawdust in a dark room. It is the democratization of materials. And don't think this is just for small materials. Architecture is already changing. The studio, The Living, demonstrated this in the heart of New York by erecting the Hi-Fi Tower, a 13-meter structure made entirely of grown bricks. They used corn waste and mycelium, and in just 5 days, the bricks grew to fill the molds. The most impressive thing is not how they are made, but what they can withstand. In lab tests, an industrial blowtorch has been placed against one side of these bricks with a chocolate bar stuck to the other. The result? After minutes of direct fire, the chocolate doesn't even melt. It is a thermal insulator superior to many synthetic materials, but with one key difference. When the building is no longer useful, it leaves no rubble. It becomes fertilizer for the next forest. But there is one place where mycelium could be, literally, our only option for survival. And that place is not on Earth. Imagine you are an astronaut on your way to Mars. The trip takes months. Every gram counts. You can't carry tons of cement or steel on the rocket. It's too expensive and heavy. So, how do you build a house on the red planet? NASA has an answer, and it's called mycotecture. The plan is fascinating. Instead of taking the finished house, you take the seeds. Astronauts would travel with lightweight, foldable structures impregnated with dormant mycelium. Upon arriving on Mars, they simply unfold the structure, add water, perhaps extracted from Martian ice, and wait. Then, the house grows itself. The mycelium expands, creating thick, insulating walls. And they are not normal walls. Recent studies from NASA's Ames Research Center suggest that fungal materials rich in melanin are excellent at blocking cosmic radiation, the greatest danger to humans in space. In fact, an unexpected protagonist enters here: Chernobyl. After the 1986 nuclear disaster, a fungus, Cladosporium sphaerospermum, was discovered growing inside the destroyed reactor. It didn't just survive the lethal radiation, it ate it. It used radiation as energy, just as plants use sunlight. NASA is studying this radiotrophic fungus right now. If we manage to incorporate its genetics into our Martian homes, we could have biological shields that self-repair and protect us from the worst of the universe. Living houses to keep us alive. If this has seemed surprising so far, get ready. Because we are crossing the line between biology and machine. Let's talk about computing. Your computers run on silicon using zeros and ones. It is binary. But as we saw at the beginning, fungi also use electrical signals. So, some scientists at the University of the West of England and at Cornell wondered, can we connect a fungus to a robot? The answer is yes. They have created what they call biohybrids. Robots that do not have a silicon chip as a brain, but a mycelium culture. The fungus senses the environment. If UV light hits it, which it doesn't like, it sends an electrical signal of distress. The robot reads that signal and moves its legs to walk away. It is not artificial intelligence. It is biological intelligence. But why would we want this? Because silicon is rigid and fragile. Mycelium repairs itself. If your fungal computer is damaged, it could simply scar over and keep functioning. Furthermore, they consume a ridiculous fraction of energy compared to our current processors. We are talking about the birth of wetware, hardware that is moist and alive. I know what you're thinking. Living houses, fungus-controlled robots. Isn't this how the zombie apocalypse starts? Pop culture, thanks to series like The Last of Us, has taught us to fear cordyceps and parasitic fungi. And it's true, in the world of insects, Fungi are ruthless killers and master manipulators. But could it happen to us? Don't worry, science has good news. We have a natural heat shield: your body. The vast majority of fungi, including the most dangerous ones, cannot survive our body temperature of 37 degrees Celsius. To them, we are boiling ovens. Furthermore, our immune system is infinitely more complex than that of an ant. It would take a fungus millions of years of evolution to learn how to hack our brain. However, there is a real risk, and it isn't zombies, it is climate change. As the planet warms, fungi are adapting to higher temperatures. Species like Candida auris are already starting to break that thermal barrier, causing hospital infections that are difficult to treat. The danger is not that they control us, but that they become resistant to our medicines. It is a silent arms race. In addition, mycelium material technology still faces challenges. We can't build skyscrapers out of mushrooms, yet. Compressive strength is not as high as reinforced concrete, and long-term durability against extreme humidity remains a challenge that engineers are trying to solve by baking the bricks to make them inert. We are on the verge of a new era. We have gone through the Stone Age, the Bronze Age, the Iron Age, and maybe, just maybe, we are entering the Mycelium Age. We have spent the last century trying to dominate nature, covering it in cement and plastic. But fungi teach us a lesson in humility. The most advanced technology is not the one we invented. It is the one that has been perfecting itself for millions of years beneath our feet. They are the recyclers, the communicators, the architects, and perhaps our future companions on a journey to the stars. The next time you walk through a forest and see a small mushroom peeking out from among the leaves, do not ignore it. Remember that beneath it there is an intelligent network that sustains the world, and that maybe, just maybe, it is waiting for us so we can work together.